Good morning, students. Next is electric field intensity due to a charged spherical shell. Electric field intensity find करेंगे due to charged spherical shell. Important application of Gauss's theorem or Gauss's law. So write down, please. Let us consider a spherical shell. A spherical shell with center O on which charge plus Q is uniformly distributed. On which charge is uniformly distributed. So मान लीजिए एक spherical shell है with center O on which charge Q is uniformly distributed. Let its radius be capital R. Let this point be OQ. Let OQ, radius of the spherical shell, be capital R. Now, to find the electric field intensity due to a charged spherical shell at a point, we have to consider a point on Gaussian surface. So we consider a Gaussian surface. A Gaussian surface को consider करेंगे spherical Gaussian surface like this. Spherical Gaussian surface. So let a point P on this surface such that OP is equal to small r. So हमने क्या किया, इलेक्ट्रिक फील्ड इंटेंसिटी को किसी पर्टिकुलर पॉइंट P पे फाइंड आउट करने के लिए एक गॉसियन सरफेस कंसीडर किया है. सो यहाँ पे लेट दिस डिस्टेंस OP is equal to r. So note down, please. Consider now. Imagine a Gaussian surface or Gaussian sphere outside the spherical shell. देखो, इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू चार्ज स्फेरिकल शेल हम 3 केसेस इसमें ड्राइव करेंगे. फर्स्ट केस, फील्ड outside the spherical shell. So here we are finding field outside the spherical shell. फील्ड को कहाँ पे फाइंड करना है हमने? आउटसाइड द स्फेरिकल शेल. चार्ज जो है इस इनसाइड वाली शेल पे डिस्ट्रीब्यूटेड है, बट हम फील्ड आउटसाइड इस शेल के बाहर फील्ड को कैलकुलेट करेंगे. So here at point P, we imagine a small Gaussian surface, a small area element on this Gaussian surface, Gaussian sphere, that is ds. यहाँ पे हमने एक small area element को consider किया है. Let it be ds and electric field at point this P be along this direction and let it be E. So this unit vector r cap is in the direction of this electric field. Also n cap is the unit vector which is also parallel to the direction of electric field and it is normal to the area element ds. So ये जो एरिया एलिमेंट है, इस एरिया एलिमेंट को हमने स्मॉल एलिमेंट्री एरिया एलिमेंट कंसिडर किया है. लेट इट बी, मान लीजिए कितना है, ds के बराबर. और एन कैप क्या है, इस एरिया एलिमेंट के बिल्कुल नॉर्मल में यूनिट वेक्टर है जो इस डीएस वेक्टर की डायरेक्शन को शो कर रहा है। और यहाँ पे ई इलेक्ट्रिक फील्ड है, आर कैप इज द यूनिट वेक्टर अलोंग द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, शोज द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड। So imagine a Gaussian surface outside the spherical shell, and on this surface we consider a small area element ds on this surface. Now let ds be the small area element, ds be the small area element, small area element on which unit vector n cap is normal to ds and parallel to direction of electric field. So now according to Gauss's theorem या Gauss's law or Gauss's theorem, E dot ds closed surface integral of electric field, it is equal to q upon epsilon naught. So E ds इसको क्या लिख सकते हैं हम, closed surface integral of E in magnitude dot r cap into ds dot n cap. So it is equal to E dot ds and r cap dot n cap, it is equal to 1. So closed surface integral EDS, it is equal to E ds closed surface integral because r cap dot n cap is equal to 1. So इसको क्या लिख सकते हैं, closed surface integral of E outside and inside ds, and it is equal to E into ds small area element को integrate करेंगे तो we will get the whole surface area of the sphere, that is E into 4 pi r square OP, sorry small r square 4 pi r square at a distance point P पे find कर रहे हैं, तो E into 4 pi small r square. So now also from Gauss theorem you know that EDS is equal to Q upon epsilon naught, because EDS is equal to Q upon epsilon naught. Therefore let it be equation number 1 and this is 2. Therefore comparing 1 and 2, comparing equation 1 and 2, so 1 और 2 इक्वेशन को जब कंपेयर करेंगे, सो कंपेयर करने के बाद E into 4 pi r square you will get E into 4 pi r square is equal to Q upon epsilon naught, and E is equal to Q upon 4 pi r square into epsilon naught. So this is electric field intensity outside the spherical shell. So ये क्या है? Electric field intensity outside the spherical shell, Q upon 4 pi r square into epsilon naught. So आप देखेंगे this field is exactly same. This field is exactly same. किसके बराबर है ये field? As this field is exactly same as if charge is situated or placed at center O. At center O. So this is the field, electric field intensity outside the spherical shell. जब हमने शेल को कहाँ पे कंसिडर किया है? Outside, where charge is uniformly distributed on this inside surface. So note down please. Next, electric field. Next, second case, electric field on the surface of spherical shell. Field outside the on the surface of spherical shell. तो ध्यान देंगे, सेकेंड इज outside the field, outside the spherical shell. Field outside the spherical shell. कहाँ पे field को find करेंगे? Outside the spherical shell. So outside the spherical shell, field on the surface of, kindly ध्यान देंगे, outside हम find कर चुके, field on the surface of spherical shell. Field on the surface of spherical shell, इस surface पे field को find करेंगे. So आप देख रहे हैं कि अगर हम field को यहाँ पे find करते हैं इस point पे, then small r क्या हो जाएगा? This small r जो कि OP, P point यहाँ पे आ जाएगा, ये जो P point था, it will become at this point, it will situated at this point. Then we can say that this small r is equal to capital R. Then small r is equal to capital R, and implies you can say E is equal to, this small r is replaced by capital R, Q upon 4 pi r square epsilon naught. Q upon 4 pi r square epsilon naught or epsilon 0. E is equal to Q upon 4 pi r square into epsilon naught. So let this equation be equation number 2. And also if sigma be the surface charge density, if sigma be the surface charge density, अगर sigma क्या है? Surface charge density. If sigma be the surface charge density, then sigma is equal to Q upon whole surface area, S, Q upon S, implies sigma is equal to q into s, and whole surface area, which is sigma is equal to q into 4 pi r square, because small r is equal to capital R. So let this be equation number 3. Substituting the value of q, that is 3 in equation 2. So q, substituting q, sigma is equal to q upon s. सिग्मा इज इक्वल टू, ध्यान देंगे, सिग्मा इज इक्वल टू क्यू अपॉन एस, चार्ज पर यूनिट सरफेस एरिया, कंटिन्यूस चार्ज डिस्ट्रीब्यूशन में हमने पढ़ रखा है. सिग्मा इज इक्वल टू क्यू अपॉन एस, सिग्मा इज इक्वल टू क्यू अपॉन एस, सिग्मा इज इक्वल टू क्यू अपॉन एस. ध्यान रखा करो, बोलते नहीं हो आप. Sigma is equal to Q upon S. So Q is equal to sigma into S. So Q is equal to sigma into 4 pi R square. Let this be equation number 3. Equation number 3. So 3 को put कर देंगे 2 में. Then E is equal to Q is sigma into 4 pi r square upon 4 pi r square epsilon naught. सो जो कैंसिल आउट होने वाली टर्म्स हैं उनको कैंसिल कर देंगे. 4 pi r square कैंसिल आउट विद 4 pi r square, एंड E is equal to sigma upon epsilon 0 या epsilon naught. So E is equal to sigma upon epsilon naught or epsilon 0. So ये है इलेक्ट्रिक फील्ड इंटेंसिटी. On the surface of spherical shell, that is E is equal to sigma upon epsilon 0 or epsilon naught. So next, third case is field inside the spherical shell. Third case, field inside the spherical shell. So inside spherical shell, field inside the spherical shell, inside the spherical shell. So देखेंगे, this is spherical shell on which charge Q is distributed. So here, so this is capital R, point O. Inside Gaussian surface को consider करेंगे. Inside, so point P be here, and electric field is along this direction. Small Gaussian surface ds, small area element, this is ds, n cap unit vector. So let a Gaussian surface, Gaussian sphere inside the spherical shell, inside the spherical shell. So यहाँ पे हमने inside the spherical shell Gaussian surface को consider किया है, inside the spherical shell. So यहाँ पे आप देख रहे हैं जो रेडियस है जिसके ऊपर चार्ज डिस्ट्रीब्यूटेड है वो कौन सा है, कैपिटल आर एंड इनसाइड द स्फेरिकल शेल जिसको कंसिडर किया गया है गॉसियन सरफेस जिसके ऊपर चार्ज डिस्ट्रीब्यूटेड नहीं है. चार्ज कहाँ है? आउटसाइड दिस स्फेरिकल शेल. गॉसियन सरफेस के ऊपर चार्ज नहीं है. इसका जो रेडियस है वो क्या है? स्मॉल आर. सो हियर therefore small r is less than capital R, and from Gauss's law Gauss's law से you know that E into 4 pi E into 4 pi r square is equal to q upon epsilon 0 or epsilon naught eds. So ds is 4 pi r square. It is equal to q upon epsilon naught. So because q is 0, so therefore electric field is 0. So electric field क्या होगी? Electric field is 0 in this case. Electric field inside the spherical shell is 0 because q is equal to 0. So this is the third important case of electric field inside the spherical shell. So this is one of the important application of Gauss theorem, that is electric field intensity due to charged spherical shell. 3 cases में हमने इसमें electric field intensity को find किया. First case में field outside the spherical shell, second में field on the surface of spherical shell, and third one is field inside the spherical shell. So kindly note down please.